In this video we continue talking about linearizing graphs. So in the last one we linearized a couple, and there are some little mathematical tricks that we need. One is that we can rearrange equations that have addition in them. So if A is B plus C, then we can rearrange the B and the C to give us A is C plus B. So 2 plus 3 is 5, but 3 plus 2 is also 5. So there we go, we can move addition about. We can do the same with multiplication. So A is B times C. So that equally works. A is C times B. Again, as an example, if B is 2 and C is 3, 2 times 3 is 6. 3 times 2, also 6. We can do the same with division. Let's say A is B times C over D. Well, this can be written in a number of ways. We can write this. A is B over D times C. We can write this B times C over D. And we can write this 1 over D times B times C. To show that this works, let's take some example numbers. Let's say B is 3 and C is 4 and D is 2. So 3 times 4 over 2 is 6. Let's do it in this one. B divided by D is 3 over 2 times 4, which is also 6. If you don't believe me, plug it in your calculator. C over D is 4 over 2, so that's 2. 3 times 4 over 2, 3 times 2 is also 6. This one, a half, which is 1 over 2, times 3 times 4 is also 6. So all of these are the same thing. We can write this BC over D in all of the ways we've just discussed. Now this helps us in rearranging the equations. There are a couple of other things that we're allowed to do. So let's do one more example. Now, let's do this one. Say we had some experiment where we were measuring the frequency and wavelength of light. Now light travels at 3 times 10 to the 8 meters per second, so c, the speed of light, is our constant. And what we can do is we can change one and measure the other. Now it's telling us that what we're going to do is we're going to put 1 over lambda on the y-axis. So let's rearrange this as it looks like variable equals constant times variable plus constant. Y-axis, I need 1 over lambda. So if I pull the lambda over here, I get c over lambda equals f. If I pull the c down, I get 1 over lambda equals f over c. Now, using the tricks we've just talked about, we can write this 1 over lambda equals 1 over c times f. And we can always add a 0, get as many zeros as we like. This is now in the form y equals mx plus c. We're putting 1 over lambda on the y-axis, and 1 over lambda on the y-axis, and we're plotting the frequency on the x-axis. The gradient therefore is 1 upon c, and the intercept is 0. Now, this c is the intercept in y equals mx plus c. This c is the speed of light, so do be careful. So our answer then is 1 over c and 0. The point of my doing this one just then is to let you know that you don't have to plot just the variable itself. You can put 1 over the variable, you can put the variable squared, as in this example. It's also customary to put the independent variable on the x-axis, but you don't have to. For convenience, you can put them either way around you like.